See you later, Emma. Come on back. I'll wait for her to log back in. And remember, cameras need to be on, Amari, and I need to be able to see you, Amari. Thank you, Amari. Awesome. All right. Emma, you back? Emma, are you back? No? Maybe? Okay. Well, I'm recording it so she can watch the first 2 minutes if she needs to. So remember that a polynomial function is like the quadratic's a polynomial function, a linear function's a polynomial function. If we don't have variables in a denominator or variables in a power, these are going to be our polynomials. So we'll look at one example real quick. We'll be able to identify some things from this example of this polynomial function. Say we have 3x to the 4th plus 2x cubed minus 6x squared plus 4x minus 1. This is an example of a polynomial. Each of these groupings are called terms. This polynomial has 5 terms. All right. Does anybody remember what the degree would be of this particular polynomial?
4.
4. It's a 4th degree polynomial. You identify the highest power. If it's written in standard form, which this is, the highest power is going to be the first term, but sometimes they're out of order and you've got to switch them. So for this particular polynomial, the degree is 4. Welcome back, Emma. That's all we missed. We just said 4th degree polynomial. So our degree is 4. You identify that with our highest power. Can anyone tell me what the leading coefficient is? That is 3, right? The leading coefficient if you think about what these two words mean, leading means like the first one, the starting thing. If you're a line leader, you are the beginning of it. Coefficients are numbers in front of your variables. So we have coefficients, variables, powers, and then the numbers that stand alone without a variable. Sorry, that was 3. The numbers that stand alone without a variable, do we remember what those are called? So we have coefficients in the front, and what's at the end?
The non-coefficients? I don't know.
That's a good guess, but they're the constants. Things that are constant are things that can't change, right? Like that's the definition, it can't change. Okay, when something varies, when it varies, that means that it could change. There could be multiple responses. You know, when y'all used to look in the back of the book for answers and it would say answers may vary, that wasn't the answer to the problem. That just meant there were multiple answers that there could be. So if you were ever copying out of the back of the book for answers to something and you wrote answers may vary, your teacher automatically knew that you had not done that yourself because that just meant there's lots of different answers. That's not the response for it. So a constant is something that stays the same and does not have a variable. Variables are things that can change. So there's no variable with our constants. So this constant is actually singular, sorry, is -1. And where do you think the constant or this number is going to show up if we graph this polynomial? It's just the same as if we have a linear function or a quadratic. Yeah, somebody said it. It's a y. It's the y-intercept. So -1's our constant. That's going to be on the y-intercept. Okay. So our number that does not have a variable with it, that's where we're going to cross the y-axis. So we notice a lot of things just by looking at this initially. We know it's 4th degree. It's got a leading coefficient of 3. And the constant is -1, or that is the y-intercept. Okay. What's going to be nice is if we know what all the different degree polynomials look like, because that's going to help us when we're sketching our graphs. So what we're going to do next is we're going to just make a rough sketch of the first 5 degrees of our polynomials. So first, second, third, fourth, fifth. We're going to make a little tiny graph of each of those. We're not going to do the parent functions. These are just some samples of things that could be these degrees, just so you can have an idea of what could happen when we're graphing these. So we're going to have x to the first, x to the second, x to the third, x to the fourth, and x to the fifth. Do y'all remember the names of these? All 5 of these? Linear, quadratic, cubic, quartic, quintic. Just if you forgot. So linear, quadratic, cubic, quartic, quintic. Lots of Q's and C's in there. So I'm just going to do some examples. A first degree, is this a linear straight line? Second degree polynomials, that's what all of 3.1 was about. What was the shape of all those graphs? The parabola, or a U. So just put a U somewhere on here. We're not doing the parent function. We're just doing some random quadratic. Do we remember the cubics, what our cubics look like? Yeah, they kind of go like this. I'm going to do one with a little bit more of a hump or curve to it. There we go. What about our cortex? It's kind of like a quadratic, but you can have a couple more humps in the middle. So here we go with our cortex. Like that. So this is what I want y'all to look at now before we draw our 5th power. For the first power, we have one section, right? It's always increasing. For our second power, we're decreasing and then we increase. So that's 2 sections that we can have. For our third power, increase, decrease, increase. So that is 3 sections. Are we seeing a pattern? Okay. With our 4th power, down, up, down, up. So that is 4 sections. So for our 5th power, how many sections do you think we could have for our 5th power? 5. So we're going to draw it. They don't always have 5, but that's the maximum number of like increasing, decreasing sections we can have. So I'm going up and then down and then up and then down and then back up. So the number of sections of the graph corresponds to the degree. Okay. You can also look at and make a prediction or figure out the pattern with the number of max and min values. You know, max and min where we switch from increasing to decreasing, the relative ones. Do we have any maximum or minimum values for our linear function? Anywhere it switches direction? No. For our x squared, we either have a minimum or a maximum, but there's only one of them, right? For our x cubed, how many could we have? 2. Here and here. We only have 2 places where we would switch direction. For x to the 4th, 1, 2, 3. X to the 5th would be 4. 1, 2, 3, 4. So if we were going to draw x to the 6th, how many possible turning points or max or mins would we have? Possible ones would be 5. So it's always 1 fewer than the degree. Could be the number of maximum or minimum values. Also called turning points because we turn direction. Okay. All right, so those are our 5 different functions. Do we see a pattern about how the arrows are going? Anybody notice something about the arrows? Like when they're going up and down?
If it's even, they end on the same up or down scale. If they're odd, they are switched.
Yeah, if it's an even degree, your arrows are going in the same direction, which these are all positive graphs that I drew. So these are going up. If it's an odd degree, we're going down and then up. It's going to be opposite direction. Okay, so positive always is down, up, like a positive line. But odd degree, they're opposite arrows. Even degree, they're the same arrows. So this is called end behavior. And the end behavior is the direction in which your arrows are pointing. So we're going to make a tiny little chart. So your end behavior is determined by the degree, the even and oddness of it, and also whether it's a positive leading coefficient or a negative, because that will tell us if we're upwards or downwards. These are all positive, so we'll start out with those, and then we'll do the negative kind. This is degree or your power. These are your leading coefficients. So all the ones that we did on top were all positive leading coefficients, positive graphs. So for our ones that were even and positive, both of our arrows were pointed upward, right? Don't make the arrows for this whole box. We're going to write something underneath them. So this is an up arrow and an up arrow. Even degree. These were both positive graphs. My arrows are going up. Okay. Odd degree, positive graphs. The first arrow is down. The second arrow is up. If those are the positive ones, how are we going to get the arrows for when it's a negative in the front? What do we need to do with those arrows?
Flip them.
You're going to flip them because it's going upside down. So an even negative, they're both downward. And an odd negative, instead of like increasing that way, we're going to be decreasing. So we start up and finish downward. Okay. So this is probably how you did in Algebra 2. You wrote your arrows for end behavior. But now we're going to start using infinities instead of the arrows when you're writing your answers. So underneath each of these, we're just going to write which type of infinity it corresponds to. So if it's an up, we're going to do positive infinity because it's going to positive infinity. If it's a down, we're going to write negative infinity. Okay. So if it's an up arrow, instead of doing up, we're going to use positive infinities. If it's a down arrow, we're going to use a negative infinity. Okay. So we have statements that we're going to have to write using our infinities. This is going to get you to where you're familiar with this format. So when you get into calculus, you're able to do the limit definition of all of these, and you'll see that later on. But this is just an introduction to a new form of writing the end behavior. Okay. So we're going to do 2 graphs with the statement way and then 1 with an equation. So this is example, we'll do A, B, and then C. Change that 7 to, no, it's fine, 7. Lee, are you okay? No, you're not? Okay. I didn't think so. Okay. All right. So these are the statements that you're going to be filling in or you'll be writing for this. And this is how it goes. It's going to start like this. It's going to say f of x goes to something as x goes to negative infinity. That's statement 1. And f of x goes to something as x goes to positive infinity. So this is what you're going to be writing, but the only thing that's going to change are the 2 things that are in these spaces. Everything else is just the format that you'll write every single time. Okay? So we have to decipher what this actually means. All right, there's at least 5 people that are just texting folks during this whole entire time. Remember, you should be paying attention to what's going on here and your camera should be on. All right. So what this means is we're trying to figure out what's another word for f of x or another letter for f of x. Y, right. What's going on with the y value as x goes to negative infinity? X goes to negative infinity is just saying what's happening on the left. Because if you think about your number line, is it negative infinity on the left-hand side and positive infinity on the right-hand side? So when they say x goes to negative infinity, this just means look at your left arrow. That's telling you on the left-hand side, what's happening with your y value. Okay, and we'll fill it in a second. And in the same way, as x goes to positive infinity, this is asking you about the right side or the right arrow. Okay, so let's go back to our top line. It's saying as x goes to negative infinity. That means this arrow right here. Is this going up or down? Is this an up arrow or down arrow? This is an up arrow. So since this is an up arrow, we'll write positive infinity. That's because this one was going upwards. So when they say as x goes to negative infinity, that means, okay, I'm going to look at my left arrow. That's the one on the left-hand side. It was going up, so I'm going to put positive infinity. Okay. Now my right arrow, that's this one. Is it going up or down? It's going down. So what kind of infinity am I going to write? Negative. Good job. So the things that you fill in are the f of x things. The other part is just comes standard every single time. So you're just saying, and you'll if you write it in this format, this is just saying what's the left arrow, what's the right arrow. This one was going down. Okay. So let's try the next one. F of x goes to, we'll figure it out in a second, as x goes to negative infinity, and f of x goes to wherever as x goes to positive infinity. Okay. All right. I like this kind because the arrows are going in the same way. So could you really even screw this one up?
No.
No. What are they both going to be?
Negative.
Yeah, they're both going to be negative infinity because they're both going down. But let's just double check it. As x goes to negative infinity, that means check my left arrow. There's my left arrow. It's going down, so I write negative infinity. My right arrow, that's also going down, so I put negative infinity. Good. Sometimes you're not given a graph, you're given an equation. So you've got to figure out, is this a positive graph, a negative graph, an even graph, or an odd graph? Okay. So is it a positive or negative graph? Just first off, looking at this. It's negative, so we just know this is negative. And what type of number is 7? Odd. This is a negative odd graph. A negative odd graph, if we think about it, positive odd is down, up, but this is flipped. So negative odd is going to be up and down. So before I start writing my statements, I always go through positive or negative, okay, even or odd, that's odd. And if I need to go back and look at the chart while it's getting in your brain, that's fine, but that's an up and then a down. All right, so y'all write your statements real quick, and then you'll see, and then show it to me when you got it, and we'll see how you did. Scoot it over a little bit, Spencer. It fell over. Other way. Your statement. There you go. Oh, have you written your statements, your f of x stuff? Yes, Marlon, that's good. Jeremiah, is it the last one that you did? Yes, Jeremiah, that looks good. Trishelle, that's good. Emma Eaton, yes. Kashana, yours is a little bit blurry. Same thing with Jason. It looks good, but I can't really see exactly. Armani, yes. Dalen, double check that and see again. Daniel, your paper was upside down and I couldn't read it. Is that Kashana? Let me see. Sorry, I zoom in. Sorry, that's good. Kashana, it's still blurry. I need to up my resolution. I can't see the bottom part, sorry. Deborah, come closer. Closer. Closer.
Could you see mine, Miss Roselle?
Yeah, I got yours, sorry. Deborah, that's good. Hey, anybody else wanting to show me and check it? This was a negative odd, which is exactly the same as the first one that we just did. So our f of x, I don't like to do this part until I have the whole statement. So as x goes to negative infinity, that means the left-hand side, it's going to be a positive. And as x goes to positive infinity, that's my right arrow. That arrow is going down. Sometimes you'll see it written with the as x part first. I like to say that, but occasionally the f of x is first. So sometimes it says as x goes to negative infinity, f of x goes to this. So either way, just know that you're filling in the y section. They're giving you the x part. All right, now we're going to find some zeros and some y-intercepts and sketch some graphs. Anna, go quickly. I like this part the best in this section. So we're using zeros to graph. Zeros are just the x-intercepts. You might also hear them called roots. Also zeros. Also solutions. All four of those words mean the same thing in relation to a polynomial. And I use them interchangeably. So make sure that you're familiar that an x-intercept, a zero, a root, a solution, those are all the exact same things. Okay. We're going to use what we know about in behavior, what we know about y-intercepts, and what we know about x-intercepts or solutions to polynomials to be able to rough sketch. We're just rough sketching today. You have to have those three things on your graphs, but the max and mins, and they don't have to be exactly in the right spot. So here's our first one we're going to do. Sometimes you get lucky and things are already factored for you. In which case, yay, that's so great. We don't have as much work to do. So if we're looking at this, we want to figure out, if we can, what our in behavior is. And also our y-intercepts. We're going to find those first before we go through our zeros and our graphing. So to find our in behavior, which is our arrows, we need to know what degree polynomial this is. So if you see this, what degree polynomial would you think it is? Third? Yeah, it's a third degree polynomial because when you multiply it out, your highest term is going to be x to the third, right? If you just do x times x times x, that's going to be our leading term, which will be x cubed. So you can multiply your initial x's together, and we know this is a positive x cubed graph. It's positive because there's no negative sitting out in the front of it. So if we have a positive x cubed, what would our in behavior be for a positive x cubed? Dalen, what are our arrows going to be? So it's positive odd. They're both up on an odd. It's positive.
So it's just it's five. Is it positive odd? Just a 3 behind it.
All right, Dalen, one more try.
Let me try.
I'll let Dalen try. He fell asleep, so I had to wake him up.
Okay. I got a question.
Yes.
Is it positive odd because it's a 3 behind it?
Yeah, because there's 3 x's, 1, 2, 3. So that's why it's odd third power. Positive, there's no negative in the front of any of our x's. All right, Dalen, let's go back up to our chart. We said positive, odd. So what are our arrows? Okay. Poor Dalen, yep. Down, up, thank you. So this is down, up. We're going to use that when we're graphing, okay? So now let's see if we can find our y-intercept. We don't have a constant just sitting right there, but the way that we can find our constant If you plug 0 in for all your x's, that's going to give you your constant because all your variables are going to go away, right? So if I plug in 0, this is just going to be 2 times -3 times 4. So you just use your constants that you have in the end of all of your factors and multiply them together, and that's going to give us our y-intercept. So someone tell me 2 times -3 times 4.
-24.
Right, so our y-intercept is -24. So we need to know how the graph is going to go, down, up, and then what the y-intercept is. We got that by just multiplying these last numbers. Now we're going to find our x-intercepts. This is what y'all have done so much of before in your life. What would be our x-intercept if we have this first factor? The same as finding a 0 or a root or a solution. What would our solution be? Yep, -2, thank you. What's our next one? +3. And our last one is going to be -4. Okay. So we're going to put all this together on a graph. Since it's just a rough sketch, I think they're a little bit more fun than having to do exact stuff. But I do need these 3 points and the y-intercept and the right arrows. Maybe your graphs can be as pretty as mine. Just kidding. Mine are horrible. I'm going to cheat down here because I'm not going to make 24 tick marks. I value my time. All right, so let's go ahead and put our points on there. X-intercepts go on the x-axis. So we have a point at -4, a point at -2, a point at 3. Y-intercepts go on the y-axis, so a point at -24. Okay, and then we know it starts down and ends up. So we start down, end up, and we're just going to fill in between it. The only times it touches the x-axis are on these actual points. So don't just make a bunch of loops in the middle. You can only touch the x-axis at those 3 points. So we're going to go up. We have to get back down. We're going to hit our -24 and come back up to here. Raise your hand if you remember doing this last year. You remember this happening? Okay. Most of you do. All right. It was before the pandemic, so that's helpful at least. Sometimes you're not given it in factored form. You've got to do the factoring first. So we're going to do 2 different types of factoring. Then we'll talk about multiplicity and we'll be done today. And you'll have probably 20 or so minutes to work. So before we factor, let's write down everything that we know in terms of the end behavior and also our constant, which will give us our y-intercept. Okay. So what degree polynomial do we see? Third degree. Is it positive or negative?
Negative.
Well, look in front of the power. There's no negative sign there, so it's a positive odd. So your leading coefficient would be just a +1. So we're looking at a positive odd. So let's see, Dalen, what's the end behavior for a positive odd? positive odd. It's the exact same one we just did. Same as last time, yes. So what's that going to be?
He said it right the first time.
No, that was from the last example.
Probably it.
That's okay. All right, Dalen, it's down up. All right. A line that goes like this is a positive line. Yes, Dalen? Dalen, look at this line at your screen. This is a positive line, right? It starts down and ends up. So this was a positive, so it's going to be down up. This is a negative line, like a negative slope. It would be up, then you go down. Okay, so positive odd, we know that is down, up. Let's look at the constant. Is there a number that's by itself at the end? No, so our constant is 0. There is not one. So we're going to put y-intercept is 0. It's going to cross at the origin. I don't need to write these lines down. All right, now we're going to factor, but we do know it is down, up, and it crosses the y-axis at 0. What is in all three of these terms? You can just show me with your arms. What's in all three of those?
X.
An x. So our x is getting pulled to the front, which will make this x squared minus 2x minus 3. So we just pulled one x out of everything. Okay, we're going to continue to factor this quadratic. Y'all try it first, and then I'll tell you if you got it right. I'll get you started.
I do have a quick question.
Yes, Hannah.
Do we come to this class tomorrow?
Yes.
Like, and then every day except for like Wednesday or something?
Yeah, you come tomorrow and Thursday.
Oh, okay.
Mm-hmm. Yes, Marlon, that's good. All right, so let's see. What's the only thing that multiplies to 3? 3 and 1, right? If I want to get a negative 2 out of it, I need a minus 3 and a plus 1. Now we're ready to write down our 3 zeros. What's our first one? 0, right? If you set x equal to 0, doesn't that just equal 0 if you're trying to solve it? So our first one is 0. What's our second one? 3. What's our last one? Negative 1. Anytime you have a variable out to in the front by itself, you're going to say x equals 0, like you're setting the rest of them equal to it, and that would just be 0 there. Okay. And do you remember our trick to find our y-intercept on the first one? We just multiplied our numbers at the end of our constants. Well, this would be 1 times 3, and that doesn't give us 0. So we have to remember this is just like saying x plus 0 in its own parenthesis. They just don't have to write the 0 part of it. So that's why we ended up with a 0 instead. All right, so we're going to sketch. Y'all go ahead and try to sketch with your zeros and your down, up, and see what you get. See how it goes. And I want to see every single person's paper in the whole entire class. I'll be marking it down that you showed me your work for this graph. So put your x and y intercepts on there and your up downness. Jeremiah, that's good. Emma, thank you. Marlon, that's good. Trishelle, thank you. Leah, good job. Zaria, good job. Jason, good job. Spencer, Nabjo, good job. Yeah, that's good, Maddie. Camille, that's good. Alyssa, that's good. Ashana, way to go. Lauren and other Lauren, way to go. Scoot, scoot, Kiera. Forward. I think that looks good. It's kind of hard because you don't have your light on. Armani, yes, good job. Let's see, Dalen. Lee, you need a -1, not a +1. Dalen, you did it. No, you're close, Dalen. Is that a 2 or a 3 that it crossed? Dominic, that's good. Deborah, Aaron, down. Down. Awesome. All right. Oh, some people logged off so they wouldn't have to show me their paper. That's going to be
Everything mine.
who's that? Dalen, I got yours. Lee, that you fixed it.
Okay, I got this combo, this Bugatti. Going this Bugatti, 2 V8, ain't no driving, coming this Bugatti, bitch, I'm bad.
Leave. Your music.
Let's see how long it took them. I can mute everybody, or mute him. Okay.
You still never responded to mine.
Can I see yours? I can't even. Where are you?
I was told it up for like 5 minutes.
No, I can't even see you on the thing.
Oh.
Did you mute your camera?
No, my camera is on.
It muted it. Let me see.
Catch. It's
I
not.
didn't touch it. Here you go.
Oh, okay.
There you go. Now you're back on. I couldn't even see you. There we go. Yeah, yours is good. Awesome. All right, so it looks like everybody got that correct, or if you had a little error, you fixed it. We made sure that we drew our tick marks out to -1, over to 3. We got -1, 0, 3. This is a down and an up, and we connect. All right. All right, one more that we're going to factor, just because I want you to remember this type of factoring. And then we have a couple things to say about multiplicity. We're almost done. Most of my first period got the assignment done in like 15 minutes, so it doesn't take a long. I didn't give you a really long one since it's due tomorrow. Okay, when we see 4 terms in a polynomial and we want to factor it, what type of factoring are we going to try to use? Do we remember?
Is it grouping?
It is grouping. It starts with it starts with the word group and ends with the word ing. Not really a word, but there we go. But before we go through the grouping process, let's write down what our end behavior and stuff is. This is another positive odd, because I guess I was not very creative when I was making these problems up. So this is a positive x cubed, which is another down up. And what's our y-intercept? The y-intercept is 8. That's our constant at the end. So our y-intercept is going to be 8. That's what will cross the y-axis. Okay? So now it's time to group. The thing in common with the first 2 terms is x squared. When we pull out x squared, we've got x minus 2 remaining. The thing in common with the second 2 is -4. When we pull out -4, you've got x minus 2 remaining. Look, these 2 are the same. What a coincidence. Actually, no, that's the way the problem's set up. So those 2 are the same, so that's what gets brought to the front. That's a commonality. And then we write what was in the front of them in the second parenthesis. Let's see. Didn't we put it? Is this completely factored yet? No. The x minus 2, that's fine. There's nothing else we can do with that. X squared minus 4, how does that factor? So I see a plus and minus sign. Yep, x plus 2 and also x minus 2. Now we're all the way good. We're ready to find our zeros. What's our first one? Positive 2. Good. Our second one,
-2.
and our third one is positive 2 again. So there's going to be something weird that happens on our graph because 2 is a root twice. So remember that's a multiplicity and it's going to be something strange. So we'll just put everything we know on the graph, and when we get there to that number, we'll see. So we have to get to 8, right? 1, 2, 3, 4, 5, 6, 7, 8. I got a -2, a positive 2, an 8, a down, and an up. These 2 points, -2 and 2, are the only times I can touch the x-axis. I can't make another point in there in between. These are the only 2 points where the graph is going to touch or cross the x-axis. So I'm going here at -2. I've got to get up to 8. So I'm going to go up, and then I'm going to come down after 8. But I can't go through and then come back, and that's the only time I can touch it. So I'm just going to have to hit the x-axis and turn around. Otherwise, it wouldn't be down up. Okay? So in order to make the graph satisfy everything that we wanted, I didn't get to go through the line at 2. I didn't get to go through it. I just had to hit it and turn around. Okay? You see how 2 was a root twice? This is called a double root. Or it has multiplicity 2. That's another way to say that. And it doesn't actually go through the x-axis. It hits the x-axis and bounces back up. So it makes it look kind of like a quadratic. If you zoomed in just in this little bitty space, that just looks like a little parabola there because it's 2 times. Okay. So the very last thing, which is about multiplicity. Weird things happen when you have roots that show up more than one time with your graph. So our root can have even multiplicity. That means it's a root 2 times or 4 times or 6 times. And what happens is it hits the point and bounces back, or it could be underneath, either way, but it doesn't go through at that x-intercept. It can either look like this, or if it's upside down, maybe it looks like this, but it doesn't go through, bounces back. So when you get to that root, do not cross, turn around, don't drown. You know, they say that in a flood, right? Odd just does some weird stuff when it goes through the x-axis. So if you have odd multiplicity, so it's a root 3 times or 5 times or 7 times, it just is a curly Q when it goes through it. It doesn't go straight through. It doesn't turn around. It just kind of zigzags, kind of like x cubed. So when you have an odd multiplicity root, say this was it, you start going up and then it's like that. So it's not straight through, it's a zigzag. These don't show up very much, but I did want you to know that. So we'll look at one final problem to graph. Let's have this be our graph. We have x plus 3, x minus 1 squared, and x minus 3 cubed. So we always want to know what degree it is so we can figure out the end behavior and then what the y-intercept is. If you looked at this, what would you think the degree was? Think about what a power means. A power means that this parenthesis is there twice, and this parenthesis is there thrice. So think again about your degree. How many x's would we have at the beginning of those things? If you wrote out all the sets of parentheses, how many would we have? Yeah, that's good. Sorry, and Leah, you got it. It's 6. It's a 6th-degree polynomial. This is 1. There's 2 more here, so 1, 2, 3. And then there's 3 more here because that would be 3 sets of parentheses. So this is a positive x to the 6th. So how do our arrows go on a positive x to the 6th? Yes, it's like our touchdown. Yeah, what's our touchdown sign? Yep. 6 is an even number, positive is up, so these are going to both be up. And I don't really want to do this y-intercept because it's 3 times negative 1 squared times negative 3 cubed. I think it's 81. Maybe, no, it's negative 81. I guess I just did it. But you'd have to actually cube and square the numbers for that. So that's your y-intercept. I'm not going to do 81 tick marks. So our x-intercepts, what's our first one? Negative 3. Okay. What's our second one? It's 1, and you're always going to write what the multiplicity is. So is this 1 mult 2? Because it shows up twice. That parenthesis there's 2 of those. And then our last one is 3 mult 3. I just like to abbreviate it. Fill in your zeros, arrows up. Is there anything crazy at negative 3? Any multiplicity? No, so we just go straight through negative 3. Okay, coming back up. Anything going on at 1? 1 has multiplicity 2. So do I get to go through the x-axis or do I have to turn around? I have to turn around because it's got multiplicity 2. Remember multiplicity 2 looks like this, where I've got to hit the x-axis. I can't go through it. So I hit it, turn around, got to get back up here. But 3 has multiplicity 3, so it does a squiggly because that's an odd multiplicity. Odd multiplicity means we squiggle through. So we're going to squiggle through there. I might have to redraw that arrow. So nothing fancy. Hit it, turn around, squiggle through. Nothing fancy. An even makes you turn around. An odd makes you squiggle. Did y'all do this last year? Maybe? Some of it? Okay. I was trying to remember. I don't know if we did it. Lauren, did we do this last year, Maddie? With the multiplicity? We just did it the zeros and you sketched them? Yeah. I don't think we did multiplicity though. All right, so go ahead and get started on your CUDA problems. You should be able to get at least half of them done before the 48 if you stay on that long. But just sit down right now and just get them done so you don't have to worry about them later. You only have to write down the ones that you factor. Everything else you can just look at the problem and put the answer. Okay? So it should take you no more than 20 minutes. Just go ahead and get started on it. And if you have this assignment and 3-1 done by the time class starts tomorrow, I won't take your late points off of 3-1. So those of you that haven't done 3-1 yet, if you get this one and 3-2 and they're ready to turn it in right when you come to class tomorrow, I won't take your 3-1 late points. Okay? Give you a little bit of wiggle room on that first assignment.